Alright, so this is a video on how an alternator works. Before we actually get into the alternator, just a couple of very basics. Theory: if you take a magnetic field and you move it past a wire, you tend to encourage current flow. So if I take this, this is a bar magnet, and I move it past this coil, it hooked up to a small ammeter here. You can notice that the needle is deflecting just by moving the magnet past the coil. And conversely, if I hook electricity up to a coil, I will turn it into a magnet. So let's go ahead and try that. Notice that that's not a magnet right now. If I hook a battery up, then this becomes a magnet, and if I take power away, it's not a magnet anymore. So if I move a magnetic field past a wire, I induce current flow. If I put current flow into a wire, I create a magnetic field. Okay, this is a traditional alternator, and I've removed the pulley off the front of it, and I'm going to crack it open so we can see what's inside. Okay, so in its simplest form, it's really very straightforward. This is the outer case. This is the back of the outer case, and these are windings that are circular in that outer case. That's called the stator. The stator is actually 3 sets of windings. A little bit more detail than you probably want to know, but they're basically 120 degrees out of phase from each other, and they generate 3-phase alternating current, which later we turn into direct current. This guy here is the rotor, and I don't know if it's easy to see or not, but right inside here you can see there's a winding in there. Now, what's important about that winding is that when I apply electricity to it, it becomes a magnet. At the moment, it's not a magnet. If I try to take my washer here, it won't stick to that at all. There's no magnetic properties to this rotor whatsoever until I put current into it. And I do that with brushes on these 2 copper pieces here at the end of the rotor. So each one of these copper pieces goes to the winding, and the brushes ride on that while it's spinning, and that's how I get power to the rotor. So when the rotor's got power, it then becomes a spinning magnet. The spinning magnet interacts with the stator coil, and that generates electricity under the power of whatever's driving the alternator. Okay, so there's the alternator. It's an AC Delco 334-2110. It does not have a regulator. It's simply kind of an old school alternator. Usually GM cars, mid-60s to early 70s, use this particular alternator. It does have the diodes for rectification built into it, but no regulator. Now we're going to go ahead and mount the motor. Okay, so the motor's mounted. I wasn't sure what size motor to go with, so I chose a 3/4 horse induction motor. It can be wired to run clockwise or counterclockwise. In this case, as far as the alternator is concerned, the alternator really wouldn't care, except for the cooling fan on the front of the alternator. It was really only made to cool efficiently in one direction, so that's how I wired the motor. And so this is the assembly. Got the motor and the alternator on there. Now we got to hook up some electronics and give it a go to see what its output looks like. Yeah, one more thing, a couple of things that I wanted to point out. Here on the back of the alternator we have 1, 2, 3, 4, 5, 6 diodes. That's the full wave bridge rectification for the 3-phase output, alternating current output of the stator winding. So what it ultimately does is converts that to a direct current, which is what we really want. The other comment I wanted to make is the induction motor that I bought runs at a little over 1700 RPM. The alternator is really designed to run efficiently between about 3000 and 10,000 RPM. So this is a little slower than it normally wants to run, but I'm going to go ahead and hook it up anyway and see if we can get it to get an output, even though it may not be full efficiency. Okay, here's the setup. Right now I have the output of the alternator going to a traditional brake light bulb. It's a filament bulb you'd find in some older vehicles. This is the bulb right here. And I'm going to vary the current from this power supply here. I got off Amazon, and you can see the current reading there. I'm going to vary it from about a 1/4 amp to about 1.5 amps into the rotor. So the rotor will vary in its magnetic intensity, and that then in turn will vary the output of the alternator. So this is how the voltage regulator kind of deals with things. It puts more current into the rotor to make it a stronger magnet when they want more output from the alternator, and it reduces it for a lesser need. So here we go. Hope you enjoyed it.